This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. All ketones and aldehydes do a little resonance thing, and they form an enol tautomerization. Basically, your hydrogen from down here, your acidic hydrogen, jumps up onto the oxygen lone pairs, and this double bond falls down here. See how the double bond fell? And the hydrogen came from down here. You can have an acid or base catalyzed. And if you deprotonate here, now you're even making it stronger. This is an enol, right? But this is an enol anion. It's got a negative charge to it. When you have a double bond in that oxygen, it's going to resonate. So that means your negativity can come down here. See, your double bond went up there to don't form your carbonyl, and it just resonates back and forth. But this is where that's your nucleophilic site. One thing you need to know is that carbonyl alpha carbons are acidic. See how this is your carbonyl, this one with a double bond. That carbon is your carbonyl carbon. This is your alpha carbon because it's right next to it. This alpha carbon is acidic, so you have sodium hydroxide in solution, and you have chlorine in solution. Well, I got bromine, but either way, you got a halogen in solution, and that's what makes your bleach, right? So your OH comes in, it's a base, right? It snags off this hydrogen, because this is an acid, right? It's not a good acid, but it's an acid nonetheless. So it takes a hydrogen and it ends up being in this enol anion type form, right? Now bromine, sooner or later, here and there, they dipole, you know what I mean? Just for a little bit, spontaneously. So this is positive at 1 second. So this negative charge wants to come down to make its double bond again. It wants that carbonyl, right? This double bond comes up, grabs the bromine, and you add a bromine on there. Now the thing is it was acidic before, now it's really acidic because you have a bromine here to help stabilize this when the hydrogen gets plucked off. That's what makes it a good acid. The more stable the anion is that's left, the better it can give away protons. That's what makes a good acid, giving away protons. And it can definitely do it better now because it has this bromine right there to help, and it'll help delocalize electron density there, you know what I mean? So it's just basically going to do this again. OH is going to come up, pluck another hydrogen off like it did there. It's going to form an enolate, anion, and then it's going to pluck the bromine off, and it'll have 2 bromines until it has 3 bromines. Now once it has the 3 bromines, you can see right here, it has no more hydrogens to take, right? So it just goes through a regular carbonyl carbon, this is positive. So it comes in and it does an acyl transfer, basically. Attacks the carbonyl carbon, ends up with a tetrahedral intermediate. The tetrahedral intermediate wants to collapse and reform the double bond for the carbonyl, right? Now you have 2 choices. Either the OH is going to leave as a negative, or these 3 bromines and the carbon is going to leave as a negative. Which one is more stable? This is more stable. It has all them bromines, man. But bromines love negativity. They ain't going to mind that negative charge there, especially with 3 of them there. So it kicks that off, and you end up with your carbonyl with an OH group. Here's your carbonyl, and here's your OH group. And what is that? That's a carboxylic acid. Now this needs an H somewhere to be chloroform, right? Well, you just made an acid right here. You can pluck it off of there. Or as you know, bleach is like, it's pretty much all water. You can get a proton from one of the water molecules. You can see this stays the same. So look, if you used this, we would end up with this. If we started with this and this would be our acid. If we started with this would be our acid. So you are making two things, right? And that's, you have a lot of sodium hydroxide in solution, you're going to be, changing this into a salt. Well, I only had 175 or 258 grams of the calcium hypochlorite. But here's my equation, my molar masses. I timed them by what I needed to, 1.5, times that by 1, times that by 1. These two I divided by the density so that I could get the milliliters per mole. Okay, I only had 258 grams of my calcium hypochlorite, right? So if I divide that by 68, it's only 68%, I get 175. That means there's, if I, out of that 258, there's 175.5 grams of calcium hypochlorite in there. You can see if I take it by 0.82, they're pretty much the same number. So I multiply them all by 0.82. So I'm going to have this much of the stuff I'm putting in, but only this much of it is calcium hypochlorite. This is how much acetone should be reacted, and this is my yield. Alright, I got about 260 grams of this stuff here. Shockwave for your pool. See the ingredients. Got it in there. I'm going to put in 2 liters of water. Stir that up. Let it mix. I don't know if you can see on camera, but it is green. It's definitely green. But you can see at the bottom, it's got some salt in there still. I don't know, I'm going to filter it. See, now I turned that on, got my thing on, I got my vacuum, and I put this switch on this valve so I don't have to hear this thing. It's not blowing out oil. But I still got the vacuum until this gets down there. And I can just put more in. Okay, trying to dissolve that. It was probably, calcium hydroxide, and it turned into calcium carbonate. Because when I threw it into acid, it bubbled. So I don't know. That's my guess. Here on the left, you got your calcium hypochlorite. Like I said, I added more water to try to dissolve that. I ended up having to filter it out. It was terrible. This side is just a water that I put outside, froze. It's in a nice water bath. This is actually solid in here, just on the inside, but it'll warm up. Now I got 60 milliliters of acetone, or 2-propanone. I would drip this in, but so little, I'll just put a little bit in at a time. I got a stir bar, and this started out at like 3 degrees. I mean, -3. This is -2. So I'm going to add it in a little bit at a time. You can see how this side is green too compared to this side. I don't know if you can see it on camera. Hopefully you can see the line is up to here. Alright, well, I'm going to add this one little by little, and I'll get back to you because it should. I'll get back when I'm almost done putting it in, and you'll see it turn clear. That's how you know you're done. It's only been about 5 minutes. I added pretty much everything. Oh, well, I guess I still got half left. But you can see this top half that looks white. That's actually ice. So I cooled it down too much. But now you can see the green is all down here and it's white up here. You gotta get the acetone to the bottom. Still green now. Let's give it some time. Well, as you can see, the only green part now is just this. See this slice in the middle? Then you know what I realized is this is making calcium hydroxide instead of sodium hydroxide. When you make it use the sodium hypochlorite, we're using calcium hypochlorite. Now all that calcium hydroxide looks like it's precipitating out. So that is not going to be fun, but we'll get it out of there. But you can see I only have a little bit of green left. I only have like maybe 18 milliliters, so it's almost gone. Well, there's so much precip I can't tell if it reacted or not. It is up to 9 degrees C, but there's still like a rock of ice in there. Oh, it looks clear. Well, we'll see. I'll let it do it slowly so I don't clog up the filter right away. It always starts out clear. We'll give it a second and we'll see if it's clear or not. I think it is. I think it is clear. There's no green at all. But I swear I see green in there. Just a slight tint of it. You can't see it on camera. Anyways, I'm going to filter all that crap out anyway. So this is going to take a while. Well, I filtered this twice. The green is completely away. Calcium hydroxide or carbonate or whatever that was is out. So I'm going to put some salt in here. I got 70 grams of table salt. It's right out of the thing. I didn't purify it or anything. The reason I'm doing this is because it's all one phase. Nothing came out into two phases. So we're going to see if that helps out any. I'll get back to you after I shake it up and stuff. Well, it started fizzing. And now it's turning clear again. I don't know what it was fizzing about. Well, I've been distilling this stuff. I couldn't salt it out. I probably could have, but I didn't want to jerk around with it. I just said screw it. This is the fourth. I can only get a liter in there at a time, and I had a gallon, so this is the last of it. I don't know if you can see it on film there. See that little ring inside there? There's barely any chloroform. Of course, you know what I mean. It's usually at the bottom because it's heavier, it's dense. So hopefully it all comes out right now, because if not, this is a big waste of time. So anyways, I'll get back to you when that's all done. Well, I'm done distilling it. I barely, what is that, 1-2 milliliters? This is a small round bottom flask. So, you know what I mean? So that's just a little nothing. But anyways, if I was going to do this again, and I am, I would get some HCl when I was done with the reaction and throw it in there and make all that calcium hydroxide into calcium chloride, right? That way I don't have to worry about the hydroxide and the carbonate, calcium, you know, calcium anything is pretty much insoluble. Or you know what I mean, it's not very soluble except for calcium chloride. That way also, you've seen how I have tried to salt it out. That would help salt it out. I think a lot of my stuff just maybe got stuck in the hydroxide, or when I was filtering, I'd use the pump, you know, the vacuum pump a little bit here and there. That might have sucked some out. But we'll see next time, because that's what I'm going to do. That way, I'll have a lot of calcium chloride in there. It'll easily salt out that the chloroform I'm making. And then I won't have any precip that I got to be filtering out and all that kind of crap. Anyways, just a thought. Remember, science is great.